All right, assalamu alaikum everyone. We are doing June 2023, paper 1 today, inshallah. We are just going to start in 1 or 2 minutes now. June 23, paper 1, variant 1. In the last past paper session that we had, we did difficult questions from the other two variants of this session, paper 1, 2, and 1, 3. Now today we're doing one complete paper, and then tomorrow, inshallah, on Wednesday, we will be doing difficult questions from the November 2022 papers. All of them, all three of them. If you have any questions on any of those papers, we will be discussing them tomorrow. And then on Thursday, it will be an open session in which you can ask any questions that you have from anywhere, any particular question from any paper in past papers or anywhere else. And that will be the day before your exam. Make sure that you're revising everything alongside as well. Otherwise, you don't want to, end up forgetting some concepts at the very end. Make sure that you keep revising whatever you've learned until now. All the papers that you have attempted, make sure that you go through them again as well. Don't attempt them again, but just have a look at your solutions, especially the questions that you got wrong the first time. Go through them again in these last couple of days. That's going to be important, and you want to make sure that you go through all the concepts again as well. You can make use of the notes that I shared with you from the revision workshop. Also, what I'll try is that I can make a PDF for that, although OneNote has some problems with making PDFs, but I will try that I can, get something done about that, because some people are still apparently having problems with OneNote. If you can get it working once, it is extremely helpful, by the way, because you've got all of these notes available in proper structure that you can go through, every session. You can go to one session at a time, look at all the papers individually. In a PDF, it's going to be a big file, which is not going to be as easy to navigate. In the revision workshop as well, you can see all of these notes are on different pages like these and like this for each topic. If I make a PDF out of this, that will be like a big file with many pages. So that will be relatively harder to navigate through. So if you can get OneNote to work on your devices, that will be actually much more helpful. But if not, I will be trying to make a PDF for this and share that with you as well, for you to go through all the concepts again once at least before your exam. Okay. All right. So this is the paper that we want to do today now. Paper 1-3, June 2023. Okay, sorry, this is not the one that I wanted to do. June 23, paper 1-1, this one, right? Okay. How many of you have attempted this paper already? Can I raise of hands from those of you who have attempted the paper? Okay. All right. Now for the next class, I would recommend you to go through the November 2022 papers, identify the questions that you find difficult. And then from there on, I would not recommend that you do any more past papers after tomorrow until your exam. Go through everything that you've done in the last 24 to 36 hours, revise everything. Don't put a lot of stress on yourself as in terms of doing more papers after tomorrow. After tomorrow, it should just be about revision, revising everything that you have done already. If, of course, you're someone who has still not covered a major concept, then, of course, definitely try to do that, because you don't want to end up just, skipping a major question in the exam. But if you're relatively well prepared, Then the last day, the last 24 to 36 hours, you should be spending them on revising what you have already done until now. Okay, so don't do any more past papers after tomorrow. And so tomorrow it will be the last session that we have on past papers. The day after is just going to be uh, random questions, any specific questions that you are finding difficult. We will just have a look at them. So that may have come when you are revising all your concepts and revisiting again the questions that you've attempted before while doing practice. So let's get started with this. June 23, paper 1, variant 1. Let's start with this. Okay, so let's get started. It says solve this equation 4 sine theta plus tan theta equals 0 for theta between 0 and 180. How do we solve this equation? How do we start? We have to convert it to a single function first of all. This is sine theta, this is tan theta. What we can do is we can write tan theta as sine theta over cos theta first of all. So it becomes 4 sine theta plus sine theta over cos theta, that equals 0. Multiply cos theta here. If you multiply cos theta here, let's see what we get from that. We get 4 sine theta. So I'm just basically multiplying the whole equation by cos theta so that we get rid of this fraction. It will become 4 sine theta into cos theta plus sine theta, that equals 0. You can also do it like this, that you take LCM on the left side. So you have cos theta in the denominator first, and then you can just multiply that to the right side and that will get eliminated. And you would just be left with this thing. How do we solve this further now? We can take sine theta common from the left side. So that leaves us with 4 cos theta plus 1 inside. So either sine theta is equal to 0 or 4 cos theta plus 1 is equal to 0. Now, where is sine theta equal to 0? If you think about the graph, this is what the graph of sine theta looks like. It's 0 at 0 degrees. It's 0 again at 180 degrees. So within this interval, it's not 0 at any point, right? It says theta is between 0 and 180. 0 is not included. 180 is not included. So we get no solution from this. We get no solution from this. What about the other one? This one gives us cos theta equals minus 1 over 4. How do we solve this now? We say, let's find the basic angle. Cos alpha equals 1 over 4. Replace theta with alpha, make the right side positive. Find the value of alpha from this. What's the value of alpha that we get from this? What's the value of alpha? 75.52 degrees. Thank you. 75.52 degrees. That's the basic angle that we get. Now, what we can do is we can think about the quadrants and see which quadrants are possible. Cos is negative. Where is cos negative? Cos is negative in the second quadrant or in the third quadrant. Third quadrant will go outside the interval, so we cannot consider that. We only consider the second quadrant, and the angle that we get from there is 75.52. That's the basic angle. So what's the angle theta then? Straight line is 180. We subtract from 180 minus 75.52 degrees, and that leaves us with 104.5 degrees, and that's the only solution of this equation inside that given interval. Third quadrant will go outside the interval, so that's why we just ignore that in this case. Okay, let's have a look at the next one. Now it says, find the first three terms in this expansion in ascending powers of x. 2 plus 3x whole raised to power 4. What's the binomial formula? The binomial formula looks like this: a plus b whole raised to power n, that is a raised to power n plus nc1 into a raised to power n minus 1 into b plus nc2 into a raised to power n minus 2 b squared, and so on. So all we have to do is just input values in the formula. 2 plus 3 whole raised to power 4, that's the expression that we've got here. Let's input values in this. In place of a, we have 2. In place of b, we have 3x. And in place of n, we have 4. Let's input values. We get 2 raised to power n. That means 2 raised to power 4 plus 4c1 into 2 raised to power 3 into 3x plus 4c2 into 2 raised to power 2 into 3x whole squared. We just wanted to expand the first three terms, and we've got them now. We can stop here. 2 raised to power 4 is 16. 4c1 is 4. 2 cube is 8 into 3x plus 4c2, put that on your calculator, that will give you 6, 2 squared is 4, and then 3x whole squared, that is 9x squared. Now we can simplify this, and that gives us 16 plus 32 into 3, that will be 96x, plus 24 into 9, that will be 216x squared, and that's our expansion. That's what we were looking for. Any problems with this? Is this all right? Can somebody confirm this calculation at the end? Okay, all right. Now it says, find the first three terms of the expansion in ascending powers of x for 1 minus 2x whole raised to power 5. Now that's a different expansion. We have to do that again now. First three terms of this expansion, 1 minus 2x whole raised to power 5. Again, let's just input values in that formula. It becomes 1 raised to power 5 plus 5c1 into 1 raised to power 4 into minus 2x whole raised to power 1. This whole thing should be taken as the value for b, and then we have 5c2 into 1 raised to power 3 into minus 2x whole squared. That's the first three terms. You can simplify this and you get the result from that. That means 1 minus 5, or let's just show one more step. 5c1 is 5 into minus 2x. 5c2 is 10. Put that on your calculator. That's what you get from that. Into minus 2x whole squared, that's 4x squared. Simplify this, and that gives you 1 minus 10x plus 40x squared, and that's your final result from this. That's the expansion of the first three terms from this. Let's move on. Now it says, hence find the coefficient of x squared in this expansion. So these are the two expressions that we have expanded in the first two parts. 2 plus 3x whole raised to power 4 into 1 minus 2x whole raised to power 5. That's exactly the two expansions that we have done here. What we can do is we can input those values here, the two expansions. One was 16 plus 96x plus 216 times x squared. That was the first brackets expansion. And the other one was 1 minus 10x plus 40x squared. Now what we are looking for is the coefficient of x squared. That's what you want to find out. Now, one idea is that we multiply this whole thing. That will be 9 terms. That will be a lot of work. To make it more efficient, what we can do is we can just focus on terms that are going to give us x squared when multiplied. So 16 times 40x squared, that's one thing that we want. 96x, what do we multiply 96x by to get x squared? We multiply it by minus 10x. And what do we multiply 216x squared by to get x squared? We multiply it by 1. We can simplify this now. 16 into 40x squared, we can do that multiplication. Or what I'll do is I'll just do that directly. 16 into 40, what should that be? That will be 640, I think. 640x squared minus 960x squared plus 216x squared. What does this simplify to? Minus 104, thank you. Minus 104x squared. They wanted the coefficient of x squared, so we can say the coefficient of x squared therefore is minus 104, and that's our final answer. Okay, so that's what you want to do here. That's the last part of this question. Let's move on. Now it seems function transformations. We've done a very similar question like this before, almost the exact same shape. Let's think about this. The diagram shows graphs with these two equations. Describe fully a sequence of two transformations that transform the graph of y equals f of x to y equals g of x. Two transformations that transform f of x to g of x. Now, remember what I told you about such functions? What's the first thing that you have to think about? What's the stretch? Okay. When you have to identify transformation, first of all, look for stretch. Now, what's the stretch that's happening here? Is there any horizontal stretch? Horizontally, the distance was 6 units in the initial graph. In the transformed graph as well, the width is 6 units, so nothing is happening horizontally. What about vertically? Vertically, the initial height was this. This is 3 plus 3, 6 boxes. Afterwards, it becomes 12 boxes. So it's a stretch by a scale factor of 2. That is definitely one transformation that is happening. So we can write that in the side. That's one transformation, vertical stretch. Now, we will not write it in the answer space yet because we might have to think about the order as well. Let's just write it down for now. Vertical stretch, scale factor 2. That is one transformation that's happening. What else? What's another transformation? Before you can identify that, you have to apply this transformation to this graph and then think about the next transformation. Let's apply this transformation. Vertical stretch, scale factor 2. What happens because of that stretch is every y coordinate gets multiplied by 2. So this is -3. -3 will go to -6. So that will be here. That point goes here. And then this point is at -1. That's going to go to -3. Sorry, -2. When it gets multiplied by 2, that point goes here. The point at 3 here, that will get multiplied by 2 and go to 6. And this one as well, it goes to 6. So after the stretch, the transformed figure is already going to look something like this. This is the transformed graph after applying that stretch. Okay, you can think of it as straight lines. Assume that these are straight lines. This is what you get. Okay. Now, how do you go from this green graph to that final graph? Now, this is just a shift. It's just a translation. How many units do you have to go to the left side? Take any point here. You can take this point, for example, 1, 2, 3, 4, 5, 6. That's 6 units to the left. So what do you say? That's a translation. -6, 0. Now you can write that here. Number one transformation is it's a vertical stretch, or you can say it's a stretch along y-axis with scale factor. With scale factor 2. That's one thing that you write. Number 2, you write down a translation. Writing down the word translation is important, and then you have to write down the vector. Do not write in words that it's moving to the left. Its vector is -6, 0, and that's it. These are the two transformations that are happening. Stretch has to be first, translation has to be second. That's the sequence in which you write it down. All right, and that's your final result. Let's move on. That was question number 3. The diagram shows a sector ABC of a circle with center A. You can say vertical stretch as well. Yes, you can say vertical stretch as well. So instead of saying stretch along y-axis, you can say it's a vertical stretch. Do not write multiple descriptions. There's no point of that, because if you write two descriptions, for example, if you write stretch along y-axis, then you also write it's a vertical stretch. That will be acceptable if you write both of them. However, if any of them is wrong, it gets marked wrong. So writing multiple descriptions, there's no point of that. If any one of them is wrong, you lose marks. So just write one description that you are absolutely sure about that this is the correct way to describe this. You can either say stretch along y-axis. In this case, you can say it's stretch parallel to y-axis, or you can say it's a vertical stretch. Any one of these three descriptions, okay? And that will be fine, along with the scale factor, of course. The diagram shows a sector ABC of a circle with center A and radius 8 centimeters. The area of the sector is 16 pi over 3. The point B lies on the arc BC. Find the perimeter of the segment BCD. Okay, so this is the segment BCD. We want this arc length and we want this straight line. That's going to be the perimeter. We just want these two lengths, and then we would just add them up together. How do we think about this? Remember what we discussed about isosceles triangles. Whenever we have an isosceles triangle, you should always break them into two parts and make two right angle triangles from that. It's a sector. It's a sector. What that means is this is 8 centimeters and this is also 8 centimeters. What are the angles that are equal? These two angles are equal. So we consider this side as the base of this isosceles triangle. And if we break this triangle into two parts like this, from the middle, these two triangles are going to be right angle triangles. So let me use straight line function here. Okay, so if you break it like this triangle here and the other triangle here, these are two right angle triangles such that this point is the midpoint of BC. All right, and that makes it simpler now. First of all, they're saying the area of the sector, is 16 pi over 3. Now, using the area, what can we find out first of all? Area of sector formula, what's that? That's half r squared theta. That's the area of sector formula. So area is given to be 16 pi over 3. We can replace it with 16 pi over 3 equals 1 over 2 into r squared. That means 8 squared. We can find the value of theta from this, right? We can find that first of all. What does that turn out to be? What's the value of theta? Does anyone have the value for theta? 1 over 6 pi over 6. Okay, thank you. Theta turns out to be pi over 6. Okay. Now, the value of theta is pi over 6. What we now want to do is we want to find the perimeter of the segment. For that, we need the arc length and we need the side BC. Let's find the arc length first of all. That's pretty straightforward. Arc BC. S equals r theta. Radius is 8. Angle is pi over 6. So the arc length turns out to be 4 pi over 3. Okay, that's one thing that we wanted. What else? We want the length BC. For that, we can use this right angle triangle that we have now. We know that this complete angle is pi over 6, right? That's what we found in our previous working. Now, if the complete angle is pi over 6, and it's an isosceles triangle, when we break into two parts like this, we can say this angle here is going to be half of that, and that's pi over 12. Now, use this right angle triangle, MC, this side joining M and C, that is a right angle, that's the perpendicular. That's the perpendicular of this triangle. Let's figure out what that is going to be. Perpendicular over the hypotenuse, that gives us CM over 8, and that is equal to sine of pi over 12, and that will give us the value for CM. You can see what that turns out to be. 8 into sine pi over 12. We can just evaluate that. Make sure your calculator is in radian mode for this. Sine of pi divided by 12, and that's giving me under root 6 minus under root 2 divided by 4. You can multiply this by 8. Just use decimals because the question does not ask us for an exact value. That's 2.07055. Okay. Now, what we are looking for is the length BC. So what's that going to be? We can just multiply that by 2. That will give us the complete length. 2 times cm. You can see what that is. That turns out to be 4.141. And now, what's the perimeter going to be? We just add these two lengths up, and that will be the perimeter. We can say the perimeter is perimeter of that segment. That equals 4 pi over 3 plus 4.141. You can see what that turns out to be. And you're saying the final answer is 8.33. That's the perimeter of that segment. Okay. Whenever you have isosceles triangles, I would recommend always break them into two parts like this. Make two right angle triangles out of that, and that will become much simpler. You cannot use sine rule here. You can in the right angle triangle, yes, if you wanted, you could use sine rule, but without breaking it into two parts like this, in that complete triangle, you would have to use cosine rule. You cannot use sine rule because you don't have any two pairs of angles, or yeah, you actually can. You can use sine rule in the bigger triangle as well if you want. And yes, that works. That works because you can find this angle first of all. Yes, you can find this angle using that it's an isosceles triangle. Find this angle, and then you can use sine rule as well. That's possible, but this is much quicker. In this case, since we were given the length and the angle, that is also fine. Sometimes when they want you to prove something, and they give values as, give the angle as theta, give the radius as r. In that case, it's always much more efficient to break it down into two parts like this, make two right angle triangles, and then do this working. If you use cosine rule or sine rule in those cases, it is possible to get to the final result in that case as well, but it becomes much lengthier. Okay, so you would have seen such questions in past papers where they have where they don't have numerical values, but they say that you want something in terms of r, in terms of theta, and when they have isosceles triangle like this, it becomes much more complicated if you use cosine rule. Especially sine rule is still fine sometimes, but cosine rule, try to avoid it as much as possible. That complicates things a lot. Okay. All right. Now let's move on. Yeah, of course, it will give you the correct answer. It's just going to be not very efficient in that case. It's correct, but it's not as efficient. Let's have a look at this now. Question number 5. Now it says the line with equation y equals kx minus k, where k is a positive constant, is the tangent to this curve with this equation. Find in either order the value of k and the coordinates of the point where the tangent meets the curve. Now, how do we think about this? One idea is that we do it using differentiation. We say that this line is a tangent to this curve. So whatever is the gradient of this line, what's the gradient of this line? Gradient of this line would be k. That should be the same as the gradient of this curve at that particular point. So differentiate the curve, equate that derivative to k. Right? That's one idea. You do need to use that in some cases, so you must know this method. In this case, however, if you were to equate these two functions, you would actually end up getting a quadratic equation. Since you would get a quadratic equation, you can use b square minus 4ac as well in this case, because it does turn out to be a quadratic. We have y equals minus 1 over 2x, and we have y equals kx minus k. When we equate both of them, we get something like this: minus 1 over 2x equals kx minus k. Multiply 2x on the other side, and that gives you minus 1 equals 2kx squared minus 2kx. And that becomes 2kx squared minus 2kx plus 1 equal to 0. Now, since it's a quadratic, we can use the discriminant method here as well, and that will work. If it was not a quadratic, we could not use discriminant. In that case, we would have to use differentiation. Now, how do you use discriminant here? It says the line is a tangent to the curve. What does that mean? B square minus 4ac is equal to 0. So the value for A is 2k, the value for B is minus 2k, and the value for C is 1. We say B square minus 4ac, that should be equal to 1. Input values in this: minus 2k whole squared minus 4 into 2k into 1. That should equal 0. Simplify this, and that gives us 4k squared minus 8k. 4k squared minus 8k equal to 0. And then you solve that equation. My pencil has run out of battery. I think it was not charging earlier. Okay, just 30 seconds and it will charge a bit. So you will just simplify this, find the value of k from that. And once you've got the value for k, what you would do then would be, you would solve those two equations simultaneously, and that will give you that point that you're looking for. We'll do that in a moment. Let's see how much it is charged. Okay, so we'll get to work. I'll put on charging again later. 4k squared minus 8k, that equals 0. Take 4k common outside, and that leaves us with k minus 2 inside. So either 4k equals 0 or k minus 2 equals 0. So either k equals 0 or k equals 2. These are the two possible values of k that we're getting. Now, the question says find the value of k. That means you cannot have multiple answers. You only want one answer. Now, what's that answer going to be? It says k is a positive constant. Since k is a positive constant, 0 is not possible. We ignore that value clearly, and we say this is the only possible value for k. You have to be clear about this, that k equals 2 is the only possible solution. Now, find the coordinates of the point where the tangent meets the curve. So when two graphs meet each other, how do you find that point? We find that point by solving those two equations simultaneously. Now, we already started that process of solving them simultaneously earlier, and we got to this point. So it will be much more efficient if we just input that value of k here now, and then solve that equation. If you find that confusing, just input that value for k in this equation and start solving it simultaneously. Okay, it will be more efficient to just put it directly here because you've done this work already when we equated both of them and we got to this point. So let's input the value for k directly here and see what we get from that. 2 into 2 times x squared minus 2 into 2 into x plus 1 equals 0. Let's simplify this. That gives us 4x squared minus 4x plus 1 equal to 0. It's a quadratic equation. We have to show the working for solving this. We can break the middle term like this. It becomes 4x squared minus 2x plus 1 equal to 0. And that gives us two factors, 2x minus 1 and 2x minus 1. These are repeated factors, and that was expected because it's a line that's tangent to the curve. So it should only meet at one point. It should only give you one solution. And that's turning out to be x equals 1 over 2. What about the corresponding y coordinate now? Put it back in any one of those two equations. I can input that here. Y equals minus 1 over 2x. What does that give us? Y equals minus 1 over 2 into x. X is 1 over 2. And that results in y equals minus 1. So the point that we were looking for, that turns out to be 1 over 2 and minus 1. And that's a final answer. The value of k is 2. And this is the point where the line meets the curve. Is that all right? Any problems with this? Any questions, anyone? No? Okay, all right, let's move on. So now it says the first three terms of an arithmetic progression are p squared over 6, 2p minus 6, and p. Given that the common difference of the progression is not 0, find the value for p. Now, there are two ways of thinking about this. One is, in an arithmetic progression in consecutive terms, the middle term is the average of the two terms on the sides. Okay, it's always the average. So you can take the average of the first and third term and equate that to the middle term. That's one idea. Or you could say you can find the difference of the sequence by subtracting the first term from the second term. So that will be 2p minus 6 minus p squared over 6. That's one way to calculate the difference. Term 2 minus term 1. Another way to calculate the difference is that you subtract the second term from the first term. That's t3 minus t2. So that's p minus 2p minus 6. And that gives you an equation. This equation, you just solve that equation, find the value of p from that. Let's simplify this. This is 2p minus 6 minus p squared over 6. That equals p minus 2p plus 6. Okay, now let's take all terms to one side. Or let's just simplify this first of all. This is 6 in the denominator. I'm just going to multiply the whole equation by 6. And that gives me 12p minus 6 into 6. That's 36 minus p squared. That equals 6p minus 12p plus 36. Let's take all terms to the left side or the right side. Let's take them to the right side. P squared minus 6p and minus 12p. What is that? Walaikum assalam. Is my voice lagging for everyone? No, Aima, maybe you can try joining again. Try joining the meeting again, because it's probably at your end. Okay. P squared minus 6p and minus 12p from the other side. That gives us minus 18p. And then 36 plus 36 from the other side, that will become 72. Now we can solve this equation. Can we factorize? 72 is 72. 22, no. 12 times 6, 12 times 6 works. P squared minus 12p minus 6p plus 72 equals 0. We can factorize it like this. We get two factors, p minus 12 and p minus 6. So the value of p turns out to be either 12 or 6. There is some problem somewhere. It should not have been this. Now we're getting two values. The question says the value of p. Okay, let's think about it. So we're getting two values of p from this. This is 6 and 12. we need to find the value of p. That means there has to be one answer. So let's look at the question and see. Okay, the common difference is not zero. Common difference is not zero. Now, one of them might be giving you a difference that is zero. Let's figure that out. Let's figure out the value of p that gives you a common difference of zero. If you try 12, what's this last term? That's easy to evaluate. That is 12. And 2 times 12 minus 6, this would be 18. So that looks okay. That's not a problem. If you input 6, we get 6 here, and we get 6 here, we get 6 here. So with 6, all the terms turn out to have a difference of 0. So this is giving us a difference of 0. We say this is not possible, and this is the only solution that you have. Whenever you have a question in which you're getting multiple answers, you always need to check the question statement if getting multiple answers is possible. Okay? So the question statement here will always be very exact. So in this case, they say find the value of p. That means it has to be one value of p. You can't have multiple values of p. So you have to figure out which one can be eliminated because of any condition that they've given in the question. So they're saying the difference should not be 0. So we check which one gives us a difference of 0. 6 gives us 0. So we say the only possible value of p is 12 here. Okay. In quadratic, when you're solving quadratic equations, in factorization, this step is necessary. If you're doing factorization, if you do not show the step and write down the answer directly, you do not get marks for that. If you're using quadratic formula, you at least have to input values in the quadratic formula. Minus into minus 18 plus minus square root of minus 18 whole squared minus 4 into 1 into 72 divided by 2 times 1, and then you can write down the answers after that. If you directly write down answers, you don't get marks for that answer. Okay, so don't do that. You can still do the calculation on your calculator directly, but on your paper, at least show one step where you're either showing the factorization step or inputting values in the quadratic formula step. You have to show one of them. Otherwise, you will not get marks for that. Okay, now it says using this value of p, find the sum to infinity of the GP with the first two terms. Now that's straightforward. P is equal to 12. What are the terms going to be? 12 squared over 6 and 2 into 12 minus 6. The first term turns out to be 144 over 6, which is 24 and 18. These are the first two terms. So what's the ratio going to be? We can say it's a geometric progression with these terms. The value for A is 24. The value for R, that's going to be 18 over 24, which is 0.75 or 3 over 4. Let's input values in the sum to infinity formula. A over 1 minus R, what's A? That's 24 divided by 1 minus 0.75. That will be 24 over 0.25, 24 times 4. That turns out to be 96. And that's the final answer. Okay, so that was the second part, fairly straightforward. Let's move on. Okay, now it says a curve has this equation, 2 plus 3 sine half x for x between 0 and 4 pi. State the greatest and least possible values of y. Now, as we have discussed for trigonometric functions, one possible way of finding the range is that you think of whether one cycle is completing here or not. It's 0 to 4 pi. What's the standard cycle for a sine function? It's 2 pi. This is half x. That means this period is going to multiply it by 2. So that becomes 4 pi. And that's what the interval is. Interval is from 0 to 4 pi. So one cycle is completing. That means we can just say, let's input sine of half x equals 1. And that will give you one extreme value. So that gives you 2 plus 3 into 1, and that is y equal to 5. Then you input sine of half x equal to minus 1. That will give you another extreme value. 2 plus 3 into -1, and that gives you y equals -1. The bigger value, you will say that's the greatest possible value. And the smallest value, you will say that's the least possible value. And that's it. If the cycle is completing, in this case, the cycle was completing. What's the alternative for this? When you have a graph in the next part, you can draw the graph first and then write down the greatest and least values later on. So that's actually a better idea. Sketch the graph first. If you have a graph part in that question, and then come back to the first part again, write down the greatest and least values based on your graph. Now for the graph, we use the table function. This is in radians again. So what we can do is, we've got these values marked on this. Let's just use these same values, or we can break it down into two further, just to be sure. F of x equals 3 plus 2 sine of half x. That's the function. Okay, the other way around. This is 2 plus 3. 2 plus 3 sine of half x. That's the function. You input that here. Skip g because we only have one function here. Start at 0. End at 4 pi. Step the gap that you want between values. I generally recommend dividing the interval by 8. So 4 pi over 8, that will be pi over 2. So pi over 2. And that will give you enough values. You can first skip some of those values, as in start with 2, 5, and then 2, -1, 2. If you understand what the shape is going to look like, you can draw that. If you do not understand, then plot the rest of the values, and then you can draw that. Now look at the first part. You could also write down the greatest and least values of this function using this table function as well. So you can see in this table, what's the least value? We are starting from 2. Let's see if there's another value that's smaller. It's going to negative -1. -1 is the smallest value. You just write down the -1 is the smallest value. And then you think, look at the values again. Look for the greatest value. Greatest value is 5. You write that the greatest value is 5. That's an alternative to this method in the first part as well. Use the table function on our calculator. Now for the graph, let's plot those values. At 0, we've got 2. So we have to go from -1 to 5 on the vertical axis. Let's mark those points. This is 2, this is 3, 4, and then 5. At 0, we've got 2. And then at pi, we have 5. At 2 pi, we have 2 again. At 3 pi, we have -1. And then at 4 pi, we've got 2 again. What I've done is I've plotted values, skipping one value, just to see if we can recognize the shape of the graph. So if you remember the graph shapes well, these points should be enough for you to sketch this graph. It's a sine function. What's the shape of the sine function? You just draw that shape through these points. If you're not sure, then you can draw the rest of the points as well. Break this at these points in the middle, plot those points, and that will give you a better idea of how the shape looks like. If you do not remember the shapes very well, these are going to be the other points that you get now in the middle. -0.12. You draw the graph through these points, and it looks like this. Okay. Okay, any problem with this? Any questions, anyone?
Sir,
Yes.
can you explain how we can do this without the use of a calculator, the graph?
You can do that, but that will be quite complicated without calculator. You'll have to think of transformations. Think of the sine graph first of all. So that will look like this. At a sine, the standard sine graph looks like this. You start at 0, and then at pi over 2 it becomes 1, and then it goes to pi, and then it goes to -1 here, and then goes to 2 pi again. So you start from the sine x function, and then you think of transformations. That becomes quite complicated. So you've got +2 adding outside. So you first of all move this graph 2 units up first of all. So it goes here. So the graph goes here first of all when you move it 2 units up. So it goes something like this. And then it's multiplying by 3 outside. So you increase the amplitude by 3 as well. So the baseline has already moved up by 2 units. And now because of this 3, the amplitude also gets multiplied by 3. So it looks like this now. Something like this. Right? So you get to this point. And then what else? This is half x. Half x means it's a horizontal stretch scale factor 2. So the period that was 2 pi, that gets multiplied by 2. So it's a horizontal stretch now. And that then gives you this final graph. So you have to think about transformations. For 2 marks, that's too much thinking. But that's how you do it. That's a lot of work. I would not recommend that you do it.
Okay, thank you.
Sketching graphs is the easiest using the table function on your calculator. That's exactly what we've done, Ahmed, here. Using the calculator, we just input that function here in the table function 2 plus 3 sine half x. We input that function here. I shared that calculator video the other day as well, in which you can learn how to use the table function. So I've input the function here, then input the starting value, the end value, and the gap that we want between values. And we get these x and y values. We've got this table, we just plot those points and join those points using the sine graph shape, right? Yes, in the first part, there are no marks for any working. In the first part, the 2 marks are only for these values and nothing else. Yes, Aima?
Samin, sir, what is it like? Why did you choose the number 1 and -1 specifically, like in the part 1, like part A?
Because the sine graph, the sine function, its values are between -1 and +1.
Okay.
So the extreme values of sine function are -1 and 1. So we check what happens at those extreme values. So input -1 once, and then we input 1 once.
Okay, okay.
Right? Abdul Hadi, does that make it clear for you as well? So, how to figure out if the cycle is complete or not? The standard cycle is 2 pi. In this case, that the period was multiplied by 2 because of this horizontal stretch. So the period becomes 4 pi, and this is 4 pi, so that means one cycle is complete. Although using the table function is even easier than this, just input values in the table function, you get the range directly from that. Okay, so the question is, in some questions where you have to find coordinates, for example, we did one here in the first question, in question 5 that we saw earlier. When we find x coordinate and then we want to find the corresponding y coordinate, Do we have to show this working where we input that value of x to get the corresponding value of y? Not necessarily. You can write down the final answer as well, but I would still recommend it. It'll take you like 5 seconds to write this down. Do not risk it. Still write it down. It's just one single step. It's not going to cost you a lot in terms of the time. Still, mention that it's very unlikely that they would deduct any marks for this. There's no specific mark for this in the marking scheme, but still do not risk it. You don't want to risk anything, right? In paper one, generally you don't have any problem with time. In paper three later on, yes, if you want to do something like this, you can do that. But in paper one, generally you don't have problems with time. If you have practiced enough, you should be able to complete the paper in time relatively easily. So in that case, it's better not to skip steps when they're just costing you like 5 seconds. Just write them down quickly. It doesn't, take that much time. Okay. All right, let's move on. Question number 7, part C now. It says, state the number of solutions of this equation. 2 plus 3 sine half x equals 5 minus 2x. Now, in problems like these, where you have to find the number of solutions of a specific equation, and we have drawn some graph before, we want that function on one side of this equation. We already have that here. We have drawn the function 2 plus 3 sine half x. Right, this is what we've got. We already have that on the left side here. What's the function that we've got on the right side? It's y equals 5 minus 2x. We just draw that function on this graph, and that's it. We can look at the number of solutions from that. How do you draw this line? 5 minus 2x, when x is 0, y is 5. Let's plot that point. Take another point. You can take, for instance, in terms of pi maybe. So when x is pi, what do you get at that point? X is pi, you get 5 minus 2 pi minus 1.28. So when you input x equal to pi, you get some point around here. Okay, so what we'll do is after this question, we'll have like a 2-minute break so that my pencil has some time for getting charged. Okay, so what we do is we plot that point. Minus 1.28, join these 2 points and look at the points of intersection that you get here. There's only one point of intersection. So that's what you write here. There's only one solution of this equation. And that's it. Okay. All right. Now, this is the next one that we will be doing, but we'll have a 2-minute break so that my pencil gets charged. Then we do this. You can think about it in the meantime. Think about how you'd approach this. And then we'll start with this. Okay, so it looks like we do have some relatively more difficult questions coming up next now. Eight, 9, 10, 11. Okay, so let's resume. It says the function, it only looks difficult. Okay. (2024) October, November. We've already done October, November papers, Abdul Hadi. We could have a look at I could quickly explain that at the end of this, but you have the video for that already. We did October, November, these papers 1, 2, 1, 1, 1, 3. If you missed that live class, you have those solved here as well, and also you've got the video in that playlist that you've got. Okay, all right. Let's discuss that towards the end of the session, okay? So we were doing November 23. Sure. Okay, so it says the functions f and g are defined as follows, where a and b are constants. F of x is equal to 1 plus 2a over x minus a for x greater than a. G of x is bx minus 2 for x being all real values. Given that f of 7 is equal to this, g f of 5 is equal to 4. Find the values of a and b. Okay, so it says f of 7 equals 5 over 2. What does that mean? Input x equal to 7 in this and equate that to 5 over 2. F of 7, what would that be? 1 plus 2a over 7 minus a. That equals 5 over 2. That's one equation that we get. We can find the value of a from this. Let's solve this. We can take LCM on the left side. It will become 7 minus a in the denominator, and in the numerator, we have 7 minus a plus 2a. That equals 5 over 2. Cross multiply. In fact, before that, we can just simplify this a bit first. It becomes 7 plus a there over 7 minus a equals 5 over 2. Now we can cross multiply, and that gives us 14 plus 2a equals 35 minus 5a. 7a equals 21. The value for a turns out to be 3. That's one thing that we wanted to find out. And then gf of 5, that is equal to 4. Let's find the function gf of x first of all. What would that be? G of f of x. Inside the function g, we have to input f. So g of 1 plus 2a over x minus a. All right. Now, what does this become? Let's simplify this first before we input that here, or maybe just input that directly. B into, inside this function, I want to replace x with that thing, right? So it will become b into 1 plus 2a over x minus a minus 2. That's gf of x. We can simplify this so that it becomes b into x minus a plus 2a divided by x minus a. I've taken LCM inside the bracket, right? X minus a is the denominator. This gets multiplied by 1 plus 2a, and then you have minus 2 outside. This is gf of x. Now we are given that gf of 5 is equal to 4. So that means when we input the value of x as 5 here, that should equal 4. Input x equal to 5. That gives us 5 here. Minus a plus 2, that becomes plus a, divided by 5 minus a on the left side times b minus 2, that should equal 4. Right? I've just input x equal to 5 in this. And now we can simplify this and see what that gives us. We can take LCM on the left side first. In the numerator, we've got 5b plus a times b. In fact, we already know the value for a now. We could just input that. A is equal to 3. Let's input that value here. A is actually 3. So that simplifies further. And we have 8b over 2 minus 2 equals 4. and 4b minus 2 equals 4, b equals 6 over 4, that's 3 over 2, or 1.5. That's the value for b that we were looking for. Is that all right? Okay. That's part A. Let's move on to the next one. Now it says for the rest of this question, you should use the value of A which you found in A. So in the first part, we've already found the value for A, and the value for A there was 3. Find the domain of f inverse. Now, what's the function f? F of x is 1 plus 2 times A. What was A? The value for A was 3. Divided by x minus A. X minus 3. So the function is 1 plus 6 over x minus 3. What's the domain of this function? What's the domain of this function? Domain of this function is x greater than A. That means x greater than 3. That's the domain of this function. Now, what's the domain of f inverse? Domain of f inverse would be the same as the range of f. So we can find the range of f first of all. How do you find the range of f? It's a reciprocal function. We've got x in the denominator. How do you find range of reciprocal functions? We think of the endpoints, x is greater than 3. So we think about what happens when x is equal to 3 and what happens when x goes towards infinity. We check what happens at these 2 points. When x is close to 3, what happens to this function? When x is close to 3, when x is equal to 3, you get 0 in the denominator, right? So 0 cannot be input. But when you have x slightly greater than 3, so for example, 3.00001 minus 3, you can see what's happening. 6 over an extremely small number. What would happen? It'll go towards infinity. So when we input x equals 3, the y value that we get from that is infinity. Okay? Or you can think of it like this as well. When you input 3, you get 0 in the denominator. You can think of that as infinity, right? 1 over 0, you can consider that as infinity. Okay? So when x is 3, we're getting infinity. When x becomes very large, when x goes towards infinity, what happens to the function in that case? Let's think about that. Y equals 1 plus 6 over infinity minus 3. Now, what does that mean? 6 over an extremely large number. 6 over an extremely large number. That's going to be 0. So it becomes 1 plus 0, and that is approximately equal to 1. So at 3, we are getting infinity. At infinity, we're getting 1. The extreme values for y that we have here are infinity and 1. So what's the range of f then? The range of f is between 1 and infinity, or we can say it's just greater than 1, right? Greater than 1, that's the range of the original function. This is the range of f. Now, if that's the range of f, what about the domain of f inverse? What about the domain of f inverse? That will also be the same. Domain of f inverse would be x greater than 1, and that's your final answer. Now, none of this working you have to show in the exam. This is just for your understanding, right? I just wrote it down for explaining. You can just do it on your calculator directly. Think about it directly on it. Think about it directly in your head. And that's okay. Write down the answer. After that, you only get marks for writing this down, x greater than 1. If you've written that down, that's the result that you've got. Shorter way is just to think about this in your head, right? Think about what happens when x is close to 3. It will be going towards infinity, right? So this working, you can actually think of it in your head directly. You don't have to write it down. And then think about what happens at the other extreme. If x becomes very large, what would happen to this fraction? It will approach 0. So you just have one left. So the range therefore is from 1 to infinity, and that's the domain of F inverse. Okay, so this thinking is what you have to do in your head. I just wrote it down so you can understand what we're trying to do. Okay. Aisha, that would not always work. That will not always work. So sometimes you can think of the square root that, okay, inside the square root, you can't get something negative, but that logic always does not work because, for example, if you end up getting somewhere, just as an example, inside the square root, you have x minus 1, for instance. Yes, this is valid when x is greater than 1, but this is also valid if x was greater than 9. So we are not sure if the function is further restricted or not. So don't depend on that. That will not always work, what you're saying. Okay. All right. How do you find an expression for F inverse? So you have to do it this way. Find the range of F, and then using that, you say that's the domain of F inverse. All right. Okay. Now find an expression for F inverse of X. How do you do that? You got the function f of x. What's that? This is what it looks like. F of x is equal to 1 plus 6 over x minus 3. The domain of this function is x greater than 3. Let's find the inverse. We say let y equals f of x. Y equals 1 plus 6 over x minus 3. And then 6 over x minus 3. That is equal to y minus 1. I can take this to that side and bring y minus 1 here. So it becomes x minus 3 equals 6 over y minus 1, and take 3 to the other side now. That's 6 over y minus 1 plus 3. And the inverse function that we get from this, that's f inverse of x, that equals 6 over x minus 1 plus 3. That's the expression for f inverse that we were looking for. Is that all right? Okay, so that was this question. That's what you wanted to do here now. Why is 0 not positive? Because 0 is not positive, as in, how to answer that? Numbers that are greater than 0 are positive. Numbers that are less than 0 are negative. 0 is neither positive nor negative. It's just a fact. As in, that's the definition of positive and negative numbers. Numbers that are greater than 0, they're positive. Numbers that are less than 0, they're negative. 0 is neither positive nor negative. 0 is none of them. Okay, let's have a look at this now. We did this in the revision workshop as well the other day. Water is poured into a tank at a constant. Now let's do it relatively slowly. Water is poured into a tank at a constant rate of 500 centimeter cube per second. The depth of water in the tank t seconds after filling starts is 8 centimeters. When the depth of water in the tank is 8 centimeters, the volume is given by this formula. So we've got this volume formula given. We want to find the rate at which h is increasing at the instant when h is equal to 10. The rate at which h is increasing. What's that? That's dh over dt. That's what you want to find out. What are we given? We are given that water is being poured into a tank at a constant rate of 500 centimeter cube per second. Water is being poured at a rate of 500 centimeter cube per second. Okay. What does that mean? dV over dt, that is equal to 500. Water is measured in volume, right? So that's dV over dt, that equals 500. Okay, what else? That's all the information that we've got. dH over dt, how do you find that? You can use chain rule for this. How do you make the chain? It would look like this. dH over dt, that's going to be a product of two fractions, with the first fraction having a numerator of dH and the second fraction having this denominator dt, and then in the remaining places we've got the third variable, which is v in this case, so that's dv and dv. Now dv over dt we already know that's 500. What about dh over dv? For that we will need to differentiate this function that we are given. Let's find the derivative of this now. V is equal to 4 over 3 into 25 plus h whole cube minus 62,500 divided by 3. We want dh over dv. For that, we can find the derivative for this, dv over dh. What would that turn out to be? 4 over 3 is a constant that's multiplying, that remains as it is. You multiply by the power, subtract 1 from the power, multiply by the derivative of what is inside. The derivative of what is inside is 1. What about this? This is a constant. Derivative of a constant is 0. Simplify this and the derivative turns out to be 4 into 25 plus h whole squared. Okay, now that's dv over dh. We are given that h is equal to 10. We can input that value for h here. At that particular point, we want to find this rate of change, right? So when h is equal to 10, at that point, what's the value for dv over dh? Let's see what that turns out to be. That's 4 into 25 plus 10 whole squared. What do we get from this? 4,900. Thank you. 4,900, that's the value of dv over dh that we are getting. Input that here. We have dh over dv here, so we'll take reciprocal of that. 1 over 4,900 times 500, and that will give you the result. It turns out to be 5 over 49. You can leave it as it is if you want, or write decimals. That's okay. This is dh over dt. That's what you want what we wanted to find out. Make sense? Let's have a look at the next question now. Now the next question says, at another instant, the rate at which age is increasing, is 0.075 centimeters per second. Okay, so now this is another instant. The first part is not relevant anymore. At this instant, we are given dh over dt is equal to 0.075. What we want to do is we want to find the value of v at this instant, the value of volume. Now, how do you get volume? Do we have a volume formula? We had this volume formula that was given in the question. We can use that. We can say, this is the volume formula, right? Using this volume formula, we can find that volume. Okay. But the problem is, we do not have the value for h, right? For that volume formula, we want to find the value for h. The value for h when h is increasing at this rate, when dh over dt is equal to this. Now, how do you find that value for h first of all? What information do we have? We have dh over dt. We also have dv over dt. That is still the same, right? That rate was constant. That is still relevant. That was given at the start of the question, not inside part A. So that's still relevant here. We can say dv over dt. That is equal to 500 still. Okay, so we have dh over dt and we have dv over dt. We have already found the derivative as well, dv over dh. That turned out to be 4 into 25 plus h whole square above. That was the derivative that we found from this volume function. Okay. Now, using these two rates of change, what we can do is we can say, let's find the value for dv over dh at this particular instant. We can do that, right? We can say dv over dh. What is that going to be equal to? We can make a chain like this. The numerator of the first fraction is dv. The denominator of the second fraction is dh. And here we've got the third variable. What's the third variable in this case? That's dh. Sorry, dh is already there. It's dt. So this becomes dv over dt, that's 500, into dt over dh, which is reciprocal of this, 1 over 0.075, and that will give you some value here. What do we get for this? 500 over 0.075. 20,000 divided by 3. Let's just leave it as it is. This is dv over dh. So we know now, at this particular point, When these two things are true, the value for dV over dH is 20,000 over 3. We can say, let's input that here, and that will give us the corresponding value for H at that point. And once we get the value for H, we can input that in the volume function, and we would get that volume that we were looking for. Let's input that value here. 20,000 divided by 3, that equals 4 into 25 plus H whole squared. Divide 4 on the other side, that becomes 20,000 over, so it will become 5,000 over 3 when 4 gets divided here. That equals 25 plus H whole squared. And now we take square root on both sides. We ignore the negative square root because height cannot be negative, right? So that will give us a negative value. We can ignore that. Just consider the positive square roots. That will give you square root of 5,000 over 3. That equals 25 plus H. And you get some value of H from this. You can see what that turns out to be. 15.825. Thank you. The value of H turns out to be 15.825. And now we can input that value for H back in the function. And that will give us the corresponding value for V. Now in this question, it's 3 marks. So you can actually get away with not writing this because we've already done so much working. We found the value for H, there will be 1 mark for this. We found dV over dH, there will be 1 mark for this. So even if you don't input the value for H here directly, you would not lose any mark. But still, if you have time, you can just write that down here. And that's okay. It doesn't take that long. And now you write down the answer. What's the volume that you get from this? 69888.5. Okay, 69888.5. That's the final answer that we're getting. This is not an exact answer. We can round this out to 3 significant figures now, and that will become 69900. That's the value for volume that we have at this point. Make sense? Is this all right? Okay, let's move on. That was question number 9. Now we've got 10 and 11 and also 12. Okay, we have 12 questions on this side. So we need to speed up a little now. 3 questions left. The diagram shows the part of the curve with equation y equals 4 over 2x minus 1 whole squared and parts of the lines x equals 1 and y equals 1. Okay, so we've got this x equals 1 line, the vertical line, y equals 1 line, this horizontal line. The curve passes through these 2 points. We have their coordinates given. Find the exact volume generated when the shaded region is rotated 360 degrees about the x-axis. This shaded region is to be rotated about x-axis. Now, rotation is about x-axis, right? In the shaded part, or let's look at the curve first. Between these 2 points, this is what the curve looks like. Now, if we apply the volume formula on the curve, that will give us the volume of revolution when all of this area is rotated about x-axis. Do we want the volume of revolution from all of this? No. We do not want the volume of revolution from all of this. We only want the upper part. So we have to subtract from that the volume of revolution of this area. That's the area below this y equals 1 line. So we've got 2 functions. We will find the volume of revolution from one of them, subtract from that volume of revolution for the other one. What are the 2 functions? One function, the upper function in that shaded part is the curve, and the lower function in that shaded part is this horizontal line. These are the 2 functions that we've got. Okay, now let's write that down here. What's the upper function? Y equals 4 over 2x minus 1 whole squared, and the lower function is y equals 1 line. Limits are from 1 to 3 over 2, we can say 1.5. 1 to 1.55 are the limits. Let's apply the volume of revolution formula. What's the volume of revolution formula about x-axis? It's pi into integration of y squared with respect to x. Now, first of all, we want y squared from both of them. So what's y square going to be here? Y square equals, when we square both sides, what do we get from that? We get 16 in the numerator. And in the denominator, we have 2x minus 1 whole raised to power 4. Now, since we want to integrate this, we want x in the numerator. We can write it like this. We can say this is y squared equal to 16 into 2x minus 1 whole raised to power negative 4. That's y squared. From the other function, we get y squared equals 1. These are the two functions that we've got. Now, since the limits are the same, you can subtract them first and then apply limits, or do them separately, however you prefer. Both are fine. Let's integrate this. Let's apply the formula on this. First of all, in volume, it's actually safer to do it separately. It'll save you from careless errors. In area, you can often do them together, as in subtract them first and then apply limits after that. Now, what's the volume formula? Pi into integration from 1 to 1.5 in this case. These are the limits of this function, 16 into 2x minus 1 whole raised to power minus 4 with respect to x. Let's apply the limits. Let's integrate first of all. Apply the power rule on this. 16 into 2x minus 1 whole raised to power minus 4 plus 1, that's minus 3, divided by minus 3. And the derivative of the part inside, that is 2. And now input limits. Limits are from 1 to 1.5. 1 to 1.5. To simplify this, I can write this number outside, right? 16 and 2, they get cancelled to give us 8. I can write minus 8 over 3 outside as well with pi. So that inside, I'm just left with this, and that will simplify the calculation a bit. Now I can input the limits from 1 to 1.5. Finally, input 1.5 in this one, and then input 1 minus 8 over 3 into pi times 2 into 1.5 minus 1 power minus 3 minus 2 into 1 minus 1 power minus 3. And that will give you some value. Do you want an exact answer? Yes, we want an exact answer. When we want an exact answer, you have to be very careful with your working. You have to show all steps. So let's show one more step here. Minus 8 over 3 pi times what? Inside, you have 2 raised to power minus 3. That's 1 over 8 minus 1. That will become minus 7 over 8. And that evaluates to 7 over 3 pi. Right, that's the volume that we get, 7 over 3 times pi. Okay, that's what you get from the first part of this working. Yes.
Can you scroll down a little bit? How did you get? Why are you multiplying minus 3 with 2 in the volume?
Why are we multiplying minus 3 with 2? That's the integration rule. 16 remains as it is. We add 1 to the power, it becomes minus 3. So we divide by minus 3. And we also divide by the derivative of what is inside. Derivative of 2x minus 1, that is 2. So we divide by 2 as well.
Okay, thank you.
Okay, so 7 over 3 pi, that's what we get here. Now, apply the formula on the other one. Pi into integration of 1 with respect to x. Limits are from 1 to 1.5. What does that give us? Integration of 1 with respect to x, that's just going to be x. So 1 to 1.5, input limits, you get pi into 1.5 minus 1, that is 0.5, or 1 over 2 pi. And then you get the volume from that, the final volume. What's the final volume going to be? The difference of those two numbers. The final volume is 1 over 2, 7 over 3 times pi minus 1 over 2 pi. And you can see what that gives you. Pi over 6. What do you get from this? 11 pi over 6. Okay, 11 pi over 6. And this is 7, not 1. 11 pi over 6. That's the final result that we get. Okay, so you want an exact answer, do not use decimals here, and show complete working. Show complete working, that's important. Let's move on now. Now it says a triangle is formed from the tangent to the curve at B, the normal to the curve at B, and the x-axis. Find the area of this triangle. Tangent to the curve at B, the normal to the curve at B, and the x-axis. Okay, tangent and normal at B. Let's think about that. At the point B, we have some tangent that would look something like this. At the same point B, we have a normal. What's that going to look like? That's going to look something like this. Now, it might meet the x-axis on the positive side or on the negative side. We're not sure about that. So I'm just going to represent it like this. And then we will see at the end what it turns out to be. So we've got a tangent, we've got a normal, and x-axis. X-axis is already there. So they're saying we have this triangle. Normal, tangent, and x-axis. And what we want to do is we want to find the area of this triangle. We want to find the area of this triangle. Now, one of these lines is the normal to the curve at that point. Another line is tangent to the curve at this point. Now, to find the area of this triangle, we want these points. This point here and this point here. We have the height of the triangle already. If we take the lower side, the base, if we take this side as the base, we know that the height is going to be this perpendicular. That's going to be perpendicular. So height is 1. We know that. For finding the base of the triangle, sorry about that. For finding the base of the triangle, we need these 2 points. We need this point here and this point here. How do you get those 2 points? These are the x-intercepts of the tangent and the normal. So we have to find the equation of the tangent. We have to find the equation of the normal. How do you do that? We have the point B, we've got the function. The function was y, the curve was y equal to 4 into 2x minus 1 whole squared. Whole is from minus 2. 4 into 2x minus 1 whole raised to power minus 2. That's the equation of the curve that we've got here. Okay. The point B is 3 over 2 and 1. That's the point B. Let's write that down here. B is 3 over 2 and 1. We want to figure out the equation of tangent at this point and equation of normal at this point. For that, we need the derivative. We already have the point. We need the gradient of the normal and the tangent. For that, we need the gradient of the curve at that point, first of all. That's done using differentiation. So we find dy over dx. What does that turn out to be? 4 remains as it is. We multiply by the power. We subtract 1 from the power. It becomes minus 3. We multiply by the derivative of what is inside. Simplify this, and that gives us minus 16 over 2x minus 1 whole raised to power 3. That's the derivative, right? Now in this derivative, we can input x equals 1.5, input x equals 1.5 in this, and see what that gives you. When you input x equals 1.5, what do you get? Minus 16 over 8, that's minus 2. That's the gradient of the curve. Gradient of the curve at the point B. Now, how do you find the tangent and normal at that point? We need a point and the gradient for the equations of these lines. If the point is there, that's common between both of these. That's 3 over 2 and 1, the point B. That's the point. What's the gradient of the tangent? Gradient of the tangent would be the same as the gradient of the curve, which is minus 2. Gradient of the normal, that's going to be negative reciprocal of that. Change the sign, take reciprocal, and that gives you 1 over 2. Now, can you write down the equations for both of them? Y minus y1, that means y minus 1 equals m, which is minus 2 into x minus x1, that's x minus 3 over 2. That's the equation of the tangent. Similarly, equation of the normal, what does that turn out to be? Y minus y1, that means y minus 1 equals m, which is 1 over 2 into x minus x1, x minus 3 over 2. Let's simplify this, or we just need those points, so we can just input the value for y equal to 0. We want the x-intercepts, right? These points. For that, we can input x equal to 0 in both of them. Let's input x equals 0 here, and let's input x equals 0 here to find the y-intercept. Okay. What do we get from that? When we input x equals 0 here, we get y minus 1 equals minus 2 into 0 minus 3 over 2. And we get a value of y from that. What's the value of y that you're getting? Minus 2 from this. Okay. So we have minus 2 from this. Similarly, we input x equals 0 in that other equation as well. Y minus 1 equals 1 over 2 into 0 minus 3 over 2. What about this? Okay. I'm sorry, there's something wrong here. We were finding the x-intercepts, not the y-intercept. Why are we getting values of y there? We were looking for x-intercepts. For x-intercepts, we put y equal to 0. I input x equal to 0 by mistake there. We are looking for x-intercepts, right? X-intercepts. So we put y equal to 0 for that. Input y equal to 0, and that gives us minus 1 equals minus 2 into x minus 3 over 2. What's this value? What's this value? 2. Okay. X equals 2. All right. And put y equals 0 there. That becomes 0 minus 1 equals 1 over 2 into x minus 3 over 2. What about this? Minus 3 over 2, are you sure? Minus 2 and then plus 3 over 2. 3 over 4, okay. Now 3 over 2. That's minus 0.5. The other value that I'm getting is x equals minus 0.5. These are the two values of x that I'm getting. X equals 2 and x equals minus 0.5. Now, what are these telling us? The x-intercept of the tangent, x-intercept of the tangent, that is 2. That means this point here, this point is 2. The x-intercept of the normal, what's that? That is minus 0.5. Okay, so the x-intercept of the normal, the one that we drew here, that was not very accurate. So we can just adjust that now, because from by calculation it's turning out to be negative. So it will be on the left side there. It will look something like this. How is it turning? For the normal is going to look like this, such that when it intersects the x-axis is on the left side here, right? This is the point minus 0.5. So now the triangle is like this. This is the triangle. We have to find the area of this triangle. Minus 0.5 to 2. What's that distance? That's 2.5 units, right? Minus 0.5 to 2, that becomes 2.5 units. That's the base. The base is 2.5. Height is then perpendicular to the base. This will be the height of the triangle. What's that? That's 1. Height is 1. So we can write down the area of the triangle then, half into base into height. 1 over 2 into 2.5, the base, into height, that is 1. And that gives us 1.25. That's the area of the triangle that we were looking for. Is that all right? So we were finding the area of that triangle. For that, we needed the base of the triangle. We found the x-intercept of the tangent, the x-intercept of the normal, and that gave us the length of the base. We used triangle formula, half into base into height, and we got that result from that. Not that much in terms of working for 6 marks, but it required some thinking as in how to basically find that area, which points we would need from that. You had to think about all of that yourself. So that's why it has those 6 marks. Okay, let's move on. Question number 11. It says the equation of a curve is such that dy over dx is equal to this. Where a is a positive constant, the curve has a stationary point at a minus 15. Stationary point, what does that mean? That means at this point, dy over dx is supposed to equal 0. We need to find the value of a from this. So what we can do is we can say dy over dx is equal to 6x squared minus 30x plus 6 times a. Let's input x equal to a at the stationary point, dy over dx is equal to 0. So for dy over dx is equal to 0, and in place of x, you input a, so you get 6a squared minus 30 times a plus 6a, that equals 0. You can solve this equation, see what that gives you. 6a squared minus 24a equals 0. Take 6a common, that leaves you with a minus 4 inside. So either a equals 0 or a equals 4. The question says a is a positive constant. Only 4 is the positive value. So that's what we consider, and that's our final answer. Okay. Determine the nature of the stationary point. How do you determine nature of a stationary point? Now you've got the value for a as well. So the derivative, what does that become? The derivative becomes 6x squared minus 30x plus 6 times a, that's 4. That's 6x squared minus 30x plus 24. How do you find the second derivative? How do you determine the nature of the point? To find the second derivative, the second derivative here would be 12 times x minus 30. Input that value of x here. At the stationary point, the x coordinate is a, and the value for a is 4. So let's input that value here. X equals 4. What does that give us? The second derivative turns out to be 12 times 4 minus 30. That's 18. Since that's a positive value, we say this is a minimum point. Okay, that's a minimum point. Any issues with this? All right, let's move on. Part C. Find the equation of the curve. Okay, now that's another relatively straightforward one. We've got the derivative. That is 6x squared minus 30x plus 24. To find the curve, we integrate this, right? To go from dy over dx to y, we integrate the function. What would we get from that? 6x cubed divided by 3 minus 30 x squared over 2 plus 24 times x plus c. Do not forget the c. And now we can input that point here. 6 and 3, they could cancel to give us 2. 30 and 2, they give us 15. We have a point that lies on this line, the stationary point. A and minus 15, a was 4. So we can say the point that we can input here is 4 and minus 15. What do we get from that? Minus 15, that equals 2 into x cubed. X is 4, so 2 into 4 cubed. Minus 15 into 4 squared plus 24 into 4 plus c. Make sure that you write this step, and then you can find the value of c. From that, c equals 1. Okay. C equals 1, and then we can write down the equation of the curve. Y equals 2x cubed minus 15x squared plus 24x plus 1. That's the equation of the curve that we were looking for. Okay. Can I move on? That was part C of this. All right. Part D. It says find the coordinates of any other stationary points on the curve. How do you find stationary points? You put the derivative equal to 0. So that's what you do now. Dy over dx equals 0. 6x squared minus 30x plus 24 equals 0. You can simplify this, divide by 6, and that gives you x squared minus 5x plus 4 equal to 0. Can we factorize this? It becomes x squared minus 4x minus x plus 4 equal to 0. We get two factors from this, x minus 4 and x minus 1. So x equals 4 or x equals 1. X equals 4 was already given. So this is the other one. Find the corresponding value of y for this. Y equals, what was the function? Do we have the function? Yeah, okay, we find that in the previous part. It will be 2 into 1 cube minus 15 into 1 squared plus 24 into 1 plus 1. And that gives us what? 12. Okay. Y equals 12. So the other stationary point that we were looking for, that therefore is 1 and 12. And that's our final answer. Okay. Make sense? Let's move on. The last question now, question number 12. It looks like a weird graph, weird diagram. The diagram shows a circle P with center 0, 2. Okay, so we've got this circle here that has center 0, 2, and radius is 10. Okay, so for the bigger circle, the radius is 10 and its center is at 0, 2. The tangent to the circle at the point A, tangent at point A, okay, this tangent is also shown there. Let's write that down. Coordinates of the point A, they are 6 and 10, and the center is somewhere here. This has coordinates 0 and 2. Okay, now there's a second circle with center at the point where this tangent meets the y-axis. So this is the center of the other circle where the tangent meets the y-axis. And it has radius given as well. The radius is 5 over 2 times under root 5. First of all, we need to write down the equation of the circle P. P is this the circle, the lower circle. What's the equation of the circle? X minus a whole squared plus y minus b whole squared equals r squared, right? That's the form. I'm just writing it down to remind you about this. You don't have to write it necessarily. Just write down the final equation. X minus 6, no, x minus 0 plus y minus 2 whole squared equals r squared, that is 10 squared. Okay, that's the equation of the circle. You should simplify this to write it as x squared plus y minus 2 whole squared equals 100. That's the equation that we were looking for. Now it says find the equation of the tangent to the circle P at A. Okay, so now we need this equation of this tangent, the green line. How do you find equation of any straight line? We need two things for that. We need a point and the gradient. We already have a point, the point A, that is 610. Do we have the gradient? We can find that because tangent is always perpendicular to the radius at that point. So we can find the radius, the gradient of the radius like this. Let's call this point something. Let's call this point x. We can find the radius, gradient of xa. Let's do that. Gradient of xa, y2 minus y1, that's 10 minus 2, divided by x2 minus x1, that would be 6 minus 0. And that turns out to be 8 over 6, which is 4 over 3. What about the gradient of the tangent then? It will be negative reciprocal of this. Gradient of the tangent, that will be minus 3 over 4. We have the point A given that lies on that is 610. We can write down the equation. What does the equation turn out to be? Y minus y1, y minus 10 equals m, which is minus 3 over 4 into x minus 6. And that's the equation. You can leave it like this. They have not asked you to give your answer in a specific form, so this is also acceptable. You can do that. All right. Alaikum assalam, Mustafa. Let's have a look at part C now. Find the equation of circle Q and hence verify that the y coordinates of both of the points of intersection of the two circles are 11. Okay, equation of circle Q. For circle equation, we need two things. We need the radius and we need the center. Radius is already given. Can we find the center of that circle? That's the y-intercept of the tangent. Y-intercept of the tangent. Now we already have the equation of the tangent above. What we can do is we can invert x equal to 0 on that for finding y-intercept. So that becomes y minus 10 equals minus 3 over 4 into 0 minus 6. And that will give us the value for y. What does that turn out to be? What's the value of y? 18 over 4 plus 10. That's 4.5 plus 10, 14.5. Is that 14.5? Can somebody confirm this? Yeah, 29/2, that's 14.5. That's the y coordinate of that center that we're getting, this point. This is 0 and 14.5. So now that we've got that center, we can write down the equation because we know the coordinates of the center. They are 0 and 14.5, and we know the radius of the circle. The radius of the circle is 5/2 times √5. So what's the equation of the circle then? X minus 0 whole squared plus y minus 14.5 whole squared equals 5/2 into √5 whole squared. And that simplifies to x squared plus y minus 14.5. You can use fraction here as well. It's an equation. Normally we use fractions in this rather than decimals. Equals 25 into 5. That's 125 divided by 4. That's the equation of the circle. That's one thing that we wanted to figure out here. Equation of the circle. Now they're saying, hence verify that the y coordinates of both of the points of intersection of the two circles are 11. How do you find points of intersection of any two graphs? We solve them simultaneously, right? Now, this is one circle that we've got. What's the other circle? We found the equation of that in the previous part. What was that? X squared plus y minus 2 whole squared equals 100. We want the y coordinates. Y coordinates. For finding y coordinates, we can equate the x terms, right? We can make x. We can eliminate x from this. If we make x squared the subject, that gives us x squared equals 125/4 minus y minus 29/2 whole squared. From the other function, we can get 100 minus y minus 2 whole squared. Now equate both of them, and that gives you 125/4 minus y minus 29/2 whole squared equals 100 minus y minus 2 whole squared. Now, generally, when we are looking for points of intersection, we solve the equation simultaneously. So we could solve these equations and find y equals 11 from this, okay? However, they're asking us to verify this. Verify means that we can just input that value of 11 here and show that this equation satisfies y equal to 11. And that will be much easier, much quicker. So that's what we do here. We say, let's input y equal to 11 here and show that this equation satisfies when the value for y is 11. That's what verification means. Let's input y equals 11. What do we get from that? 125/4 minus 11 minus 29/2 whole squared, that equals 100 minus 11 minus 2 whole squared. Put this on your calculator and see what you get on both sides of this equation. On the right side, I would get 100 minus 81, that's 19. So most likely what will happen would be you will get 19 equals 19, and that means the equation is satisfied. So this is the point of intersection, and that's what you had to prove here. Is that all right? Okay. All right. Now it says find the coordinates of the points of intersection of the tangent and circle Q, giving the answers in third form. Okay, tangent and circle Q. Now we have to find these coordinates. Tangent and circle Q. So this is one point here, and this is another point here. No, this is not the other point. Point of intersection of the, yeah. So this is one point, and this is the other point. We have to find the coordinates of these 2 points. That is 3 marks. Okay. Could we have a direct way of doing this somehow? Can we use the vector method? Okay, it's not going to be very straightforward. So, okay, so we have to find points of intersection. Let's do it the normal way then. We have the equation of the circle Q, which we found in the previous part. This was the equation, right? That was for circle cube. Let's write that down here. X squared plus y minus 29 over 2 whole squared equals 125 over 4. And equation of the tangent, what was that? That was this, y minus 10 equals minus 3 over 4 into x minus 6. Okay, so we have to solve these two equations simultaneously and see what points we get from this. What I can do is I can make y the subject from the straight line. First of all, what does that give us? Y equals minus 3 over 4 times x plus 18 over 4, that's 4.5, plus 10, 29 over 2. Okay, so that's 29 over 2. This is what the equation becomes when we make y the subject. Put that value in the other equation. Put y equals minus 3x over 4 plus 29 over 2 here and see what that gives you. X squared plus minus 3 over 4 times x plus 29 over 2 minus 29 over 2 whole squared equals 125 over 4. In such problems where you have to solve equation of a circle with something else, simultaneously, I would recommend before you expand this, input that value, substitute that value here before expansion. That will simplify your working in some cases. For example, in this case, you see what's happening? 29 over 2 minus 29 over 2, they get cancelled. So the simplification now becomes so much simpler as compared to if you were to expand this first and then do the substitution, that will become much longer. So do the substitution first and then simplify that afterwards. So in this case, what do we get now? We have x squared plus minus 3 over 4x squared. What would that be? 9 over 16x squared. That equals 125 over 4. 25 x squared over 16 equals 125 over 4. And that will give you x squared equal to something. First of all, 125 into 16 divided by 4 and 25, that's 20. X squared turns out to be 20. So we can say x is equal to plus minus square root of 20. Now, they have asked you to give your answer in third form. This is third form, so you have to give your answer in this form. If they had said simplified third, we would write it as 2 under root 5. How do you do that? Just put that in a calculator. Square root of 20, and that gives you 2 under root 5. In this case, they have not specified that you want simplified surds. So square root of 20 is also going to be fine. You can just leave it like this as well, and that will be okay. So we're getting two values of x from this. Input those values of x here. X equals under root 20 and x equals minus under root 20. What do we get from that? Y equals minus 3 over 4 into under root of 20 plus 29 over 2. And y equals minus 3 over 4 into minus under root 20 plus 29 over 2. Now we've done so much working for 3 marks already, so we'll just put this on our calculator directly now and see what that gives us. Minus 3 over 4, put this on a calculator directly, minus 3 over 4 into square root of 20. Put it exactly like that, 29 over 2. And that's giving me y equal to 29 minus 3 under root 5 divided by 2. And the other value is with a negative sign there. That's 29 plus 3 under root 5 divided by 2. They wanted the coordinates of those 2 points. So now you can write this in coordinate form. You can say the coordinates therefore are, with under root 20, you're getting this. So you have under root 20 and 29 minus 3 under root 5 over 2, or minus under root 20 and 29 plus 3 under root 5 whole divided by 2. These are the 2 points that we were looking for, and that's our final answer. Is that all right? Okay, so that was the last question. There were just a couple of parts that were maybe a bit tricky in this paper. Otherwise, it was all fine. Now, in the next class, that's tomorrow, we will be doing difficult questions from November 2022 papers, inshallah. Difficult questions from November 2022 papers, all variants, right? The 3 variants, we will just do the most difficult questions from those 3 papers tomorrow, inshallah. Okay. And then the day after tomorrow, we will just be, discussing some final tips, any hard questions that you find in other papers that you want to discuss, we can do that. But we will not be attempting a full paper on Thursday. So that's the plan for the next 2 days now, inshallah. You can keep practicing for the next 24 hours at least, and then make sure that you revise everything as well. Okay, so that's it. I'll see you again tomorrow. Allah Hafiz.